going to discuss about the older tool, that is NEMI, NEMI, National Environmental Method Index. So this is one of the oldest technique, or the first developed technique or the tool for assessing the greenness of the method. Yeah, this is one of the oldest technique, or the first technique developed for assessing the greenness of the method. And previously, there was just a theoretical assumption like, so we need to change the or replace the solvents, toxic solvents or the costly solvents, or we need to minimize the utilization of the solvents, and we need to miniaturize the methods. All the approaches we have discussed theoretically, all those things were discussed, and there is no particular metrics or the tools to analyze whether the method is green or not. So in such a situations, there is a necessity to develop a tool or a metrics to assess the greenness of the method. So this is the first classical method developed, and this is just a qualitative method. So instead of giving the score rating or scores, it is just indicating whether the method is a green method or not. So that's what that is the information given by National Environmental Method Index. So how it is created? It is utilizing the principles of green analytical chemistry, whatever the 12 principles we have discussed. So consolidating all those things, it is considering that one, and this is based on those 12 principles of green analytical chemistry or green analytical technique. So this is a very oldest tool, and it is having some advantages and also some disadvantages. And while developing this tool, so some acceptance criteria were set down. So in order to understand whether the developed method, or in order to interpret whether the developed method is a greener one or not. So for that, they have considered 4 different parameters related to the amount and nature of the chemicals, pH range of the reagents or the chemicals, and how much of the waste is generated, and is there any hazardous nature to the reagent. So like that, the 4 different parameters were considered. This thing we have already discussed when we are discussing about the green solvents, and this can be applied as a tool also. Yeah. So it is based on the 12 principles of the green analytical chemistry or the green chemistry. And I'll show you the diagram so that you can understand it easily. Now, this is the diagram, so which is having 4 quadrants in a circle. So a circle is present, that circle is divided into 4 parts. So first part is indicating the nature of the chemicals, that is whether the chemical is a persistent or bioaccumulative or toxic. So if any of your reagents used in the method are persistent, bioaccumulative or toxic, you should not fill this part into a green. So if no chemicals related to this one are there, so if there are no chemicals related to this segment, so you can fill this as a green. So your chemicals should not be persistent, bioaccumulative and toxic. So if they are present, so you should not fill it with green. If they are absent, you can fill it with green. Next, the second part is related to the hazardous chemicals. So if there is any hazardous chemicals or hazardous wastes are present, so as recommended by Troy or EPA, so and hazardous chemicals are present means, then so you should not fill it with green. So if no hazardous chemicals are there, then you can fill it with green. So this is that is indicating that so you have done the replacement of the reagents. So you are not using the PBT chemicals and you are not using the hazardous chemicals. So then automatically the first 2 segments will become green. So if you are able to apply our strategy of replacing the reagents and solvents, the first 2 quadrants will be filled with green. And then So the third part is related to the corrosive nature, that depends on the pH of the chemical or the reagents or the medium. So if you are using a pH between 2 to 12, that means it is not highly acidic or not highly basic. So it doesn't consider as a corrosive. So if any of your reagents are below 2 or above 12, that means highly acidic or highly basic, then it indicates that you are using some corrosive reagents in your method. Then you should not fill this one with green. So if you are using a soft strategies, that means when you are performing the sample treatment, so if you are using a strong acids or strong bases for extraction, that means you are using the corrosive reagents. So then in that case, it will be in white only. So if you are using some other strategies, so where you are using the solid phase extraction or solid phase micro extraction, so where you doesn't need or you need only a small amount of the reagents, in such cases, so you are not using any corrosive reagents, then you can fill this part with green. So that is, instead of using the hard one, so you are using the soft strategies. And also, if you are able to skip the step of sample pre-treatment, in most of the cases, you are not using this corrosive reagents, then also you can fill this with green, this third quadrant with green. And the fourth one, waste. So regarding the waste, some reference standards were given. It should be below 50 grams or 50 ml, like that. So definitely some amount of the waste is produced, or if you are going for the recycling process also, you can fill it with green. Otherwise, if your if the method is producing any waste less than 50 grams or less than 50 ml, then you can fill this part with green. So there is no particular software for this NEMI. You have to create it manually using any paint or snipping tools, like that. So here, if we can apply the waste minimization process or the online waste treatment, then you can fill this part with green. So we are having the four different parameters considered here. So one is the PBT, another one is hazardous, third one is corrosive, and the fourth one is waste. So if we are applying the strategy of replacing the reagents and solvents, then you can successfully fill the first two quadrants. And if we can skip the sample pre-treatment, or if you can go with the soft strategies, then you can fill this third quadrant. And if you can perform the online waste treatment or the waste minimization process, then you can fill the fourth quadrant with green. So if you can develop a method which can fill all the four quadrants into green, so then that is considered as a green method according to the NEMI, National Environmental Methods Index. So this is in detail about the tool, what to fill and how to fill, and what are the what are the standards set down for this NEMI, and we will see in detail. Yeah. So PBT, chemicals, persistent bioaccumulative and toxic list. So here, none of the chemicals applied in the procedure are listed in DFPU. So this is according to the RCRA, Resource Conservation and Recovery Act. So according to this, the waste, the hazardous waste are divided into four types, DFPA, based on their source and based on their toxic nature and all. So DFPU, if any of the chemicals are listed in any of these four types of hazardous waste, then you should consider it as a hazardous chemical. Then you should not fill this part with green. And then corrosive, the 2 to 12 range is considered as a green. If any of the reagent or solvent used is below 2 or above 12, then you should not fill this part with green. And any of the waste, if the amount of the waste produced is less than 50 gram, then you can fill this part with green. So in this diagram, half part is green and half part is white. That means, so in that particular method, the researcher have used the chemicals related to the PBT and the chemicals that are corrosive. But the researcher doesn't use any hazardous chemicals, or and the waste produced is less than 50 grams. So that's why the half of the quadrant is filled with green and half of the quadrant is not filled with green, white, just white. So this indicates that it is satisfying only 2 priorities related to NEMI. It is not a 100% green method. It is just only a 50% green method. So in detailed diagram regarding this one. So first 1/4 of the pictogram is related to the PBT chemicals which are listed in EPA's tri list. And the second one is hazardous, as we have discussed about the KFPU reagents. And then the third one is regarding the corrosive, and the fourth one is regarding the amount of waste. So if they are within the limit, so you can fill the particular quadrant with green. If they are not within the limits, you should be make it empty with white only. Then, how to calculate the NEMI for analytical method. For this, I am going to take some examples so that it will be easily understandable. I have taken the example of one research article where NHAC. So he has proposed a method for estimation of rosuvastatin by using the RPHPLC method. So he entitled the method as a green method, but he did not evaluate with green metric tools. So according to this article, so previously when there were no metrics or when there is not much awareness about the green metrics, if they are able to replace the toxic solvents or if they are able to miniaturize that one, then it was considered as a green method. But there is no particular metrics that are evaluating the greenness of the method. So at that time, the author or the researcher NHAC, he developed a method for estimation of rosuvastatin using the RPHPLC method. So we just want to evaluate that method. So where it was stated as a green method. So we need to evaluate that one. So for that, I am showing you how to evaluate. And in the literature, we have taken the step-by-step process. Here in this article, they have given like whatever the chemicals used for the analytical method. So the researcher has used methanol and ethyl acetate as a mobile phase. So here the mobile phase used were methanol and ethyl acetate. So these are not listed in the tri list or EPA tri list. So these are not at all a PBT related chemicals. So these both are not a persistent, bioaccumulative and toxic chemicals. So we can successfully fill the first quadrant with green. And the second one regarding the hazardous waste list. And here in case of hazardous waste list like a KFPU, so methanol and ethyl acetate come under the hazardous waste. So even though they are not a PBT related chemicals, but they come under the hazardous waste under U category. KFPU are there 4 different types. These two come under the U category, U154 and U112. So second quadrant should not be filled with green. So it should be left blank. It should be in white color only. And then regarding the pH, so the pH of the method is in between 2 to 12 only. So the author doesn't mention any he doesn't use any corrosive reagents like strong acids or the strong bases. So the pH of the solution is in between 2 to 12 only. So we can fill the third quadrant with green. And coming to the last step, how much amount of the waste is produced. So the author has utilized the method using the solvents methanol and ethyl acetate, and the runtime was 5 minutes for this. So for each sample run, it is just taking 5 minutes time, and the flow rate was 1 ml per minute. So how much amount of the mobile phase is utilized? 5 ml for each. So for example, if you want to assay your sample, so you need to inject 5 different series of standards, and we have to inject your sample. So five standards for 5 minutes. So 5 are 25 plus your sample for 5 minutes 30, and in between some washings not more than 10 ml. So almost 40 ml of the waste will be produced. So based on the run time, it was given like 40 ml of the waste will be produced if you are running your sample by using this particular method. So it is obviously less than 50 ml of the waste. So we can consider the analytical waste as a greener one. Yeah. So you can see this one. So for the first quadrant is related to PBT. The reagents or the solvents, whatever the researcher has used, that is the methanol and ethyl acetate, they doesn't come under the PBT. So it was filled with green. And the second quadrant is regarding the hazardous waste. So the methanol and ethyl acetate comes under the U category of the hazardous waste. So we should not fill it with green. And the third one is regarding the corrosive reagents. No strong acids or strong bases or any other corrosive reagents were not used. So we can also fill this third quadrant with green. And the fourth quadrant is related to the waste. So we have calculated the amount of waste based on the runtime. So it was we got like it is less than 50 ml. So we can fill this fourth part as a green. So this is the NEMI pictogram obtained for the method developed by the researcher. So for estimating the reservoir statin using the RPHPLC method. So it is just a 75% greener. So we cannot say like it is a 75% also, it's 3/4 greener. So it is only related to the qualitative one. So whether it is a green or not, that's it. We cannot estimate it in quantitatively. Yeah, one more example regarding this one. So I have taken one more article, sustainable, eco-friendly, ultra high performance liquid chromatographic method for simultaneous estimation of caffeine and theobromine in commercial teas, and evaluation of greenness profile using NEMI and eco scale assessment tools. So this work was done by Heba Shaban and it was published in the journal. So I have provided the DOI of the article also. And this is the first page of the article. So it was published in a journal named Dietary Supplements and Traditional Medicine. So let's see what are the chromatographic conditions and how way the author has applied the greenness assessment of the development method. Yeah. So these are the chemicals utilized for this chromatographic method. One is the ethanol and another one is water. So ethanol and water are obviously a green solvents. So we can't say that we can't say that it is a toxic one. So they are green solvents, and we have to see about this theophylline, theobromine, and caffeine. So the standards used were the methyl xanthines, that is a theophylline, theobromine, and caffeine, and they are highly pure. They are almost 98% pure. And whatever the solutions prepared, that should be kept in dark at 4 degrees centigrade. So that means they are photosensitive and thermolabile. So we should keep it in dark at low temperatures of 4 degrees centigrade. And the researcher has used the filter for filtering all the solutions also. Sonicator was used. Then coming to the instrumentation, Dionex Ultimate LC system was used and a PDA detector was used. And injection volume is 2 microliters, and the Zorbax column, C18 column was used, and the flow rate was 1.4 ml per minute, and the wavelength used was 273 nanometers. So these are the chromatographic conditions for the developed method. So for estimation of the methyl xanthines. Yeah, this is a chromatogram obtained for the developed method. The first peak is related to the theobromine, and the second peak is related to the theophylline, and the third peak is related to caffeine. Next. So the author has given the data about the other previously developed methods also, about for comparing the developed method. So this is the proposed method, the method developed by the author, and these are the methods that were existed previously. So already the existed methods, and this is the method proposed by the author. So the author has used the Zorbax column, ethanol water, and the matrix is a T, and the runtime is 1.7 minutes. And then the flow rate is 1.4 minutes, almost 2 minutes for this. Flow rate is 1.4 ml per minute, and the detection is 273 nanometers. And the author has calculated the amount of waste generated, that is 2.38 ml. So because the flow rate is 1.4 ml per minute and the runtime was only almost 2 minutes, so I got 2.38 ml. as a waste for the sampling. Yeah. And after calculating all these things related to the by applying this tool NEMI, so for this particular developed method, the author has shown the greenness profile of the developed method as 100% green. So the chemicals are not PBT related chemicals. There are no hazardous chemicals, and there are no corrosive reagents, and the waste produced is also very less. So when compared with already existed method, if you compare the already existed methods, so which were not like any of the method is 100% green. So it is satisfying only two properties. So all are satisfying only any of the two properties, and here the last two are satisfying only one property, that is there is no corrosive reagent utilization. And in all the previous cases, so whatever the reagents used, they are PBT related reagents and also hazardous reagents, because they have used the methanol and acetic acid. So acetic acid is a PBT reagent, and methanol and ethanol are the hazardous waste, and acetonitrile definitely tetrahydrofuran, and the acetic acid was used and methanol was used. And here the tetrahydrofuran and acetonitrile was used, chloroform and isopropanol was used, and here also stenol. All these are the PBT related reagents and also the hazardous reagents. So it is not satisfying the four parameters required according to the NEMI. So this newly developed method is satisfying the NEMI parameters. So that's why it is completely filled with green color. One more example. Development and greenness evaluation of the spectrophlorometric methods for flibanserin determination in dosage form and human urine samples. Flibanserin is used for the erection. Uh, so here the other has developed a method for estimation of the flibanserin in dosage form and also in the biological samples by using the spectrophlorometric method. So the author has used different solvents to understand the fluorescence intensity of the given sample. So he has used different solvents. One is water, another one is methanol, and the third one is ethanol and acetonitrile. So the author has observed different intensities of the light. So like 80%, 80, 156, 289. So here, so if we compare all the solvents, the sample which was prepared using ethanol is showing more fluorescence intensity, relative fluorescence intensity. So ethanol is showing the highest fluorescence intensity, 200. So the author has selected ethanol as a solvent. So ethanol is a green solvent. So for this, so whatever the solvent used is the green solvent. Uh, so, so this is not a PBT related solvent, and it is not a hazardous one. This is not a corrosive one, and the waste produced is also very less for the sample. So that's why the author has declared that according to NEMI, this is a completely green method. Coming to the pros and cons of this method, so as we have discussed, like it is just only a qualitative method, so it cannot estimate the uh, greenness of the method in a quantitative way. So this is a qualitative method, and it is a very simple to represent, and also it is easily understandable. So we can by hand itself we can draw and we can represent, and by seeing the pictogram itself we can understand so in which parameter it is a deficient, in which parameter is not following the principles of green analytical chemistry, that we can easily identify so with the by observing the pictogram itself. So it is a simple for representation and easy for understanding also. So coming to the drawbacks or the drawbacks of the method, so it is not considering all the 12 principles of the green chemistry or the green analytical chemistry. It is mainly concentrating only on the chemicals or the waste. It is not considering about the energy consumption, what are the occupational hazards, and what is the type of equipment required, how much of power is required for that, what are the different sampling techniques that we need to use for developing the method or for analyzing the analyte. All those things are not considered in case of NEMI. And one more drawback is it is only a qualitative method. It is not a quantitative method. It doesn't give any particular score or value